Hi there! Welcome back to our channel. Today, we will have an examples on significant figures in unit conversions. So we have example number 1.1. Determine the correct number of significant figures in the following. For letter A, we'll have 1, 2, 3, 4. So we'll have four numbers of significant figures. From rule number 1, all non-zero digits are significant. But then if you'll notice, I haven't included this uncertainty. So take note, even adding or subtracting this uncertainty to this number, still you'll get four numbers of significant figures. Letter B, you'll have 1, 2, 3, 4. So we'll have four numbers of significant figures. Even for letter C. Well, again, I repeat, all non-zero digits are significant. Letter D, you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. So I've included the three zeros here, even this fourth zero here. So from rule number 2, zeros appearing between non-zero digits are significant. Letter E, I'll have 1, 2, 3, 4, 5, 6, 7, 8. So you'll have 8 numbers of significant figures. I haven't included this zero here are not significant from the rule that zeros appearing before non-zero digits are not significant. Letter F. Yes, we'll have four numbers of significant figures. Again, I repeat, zeros appearing before non-zero digits are not significant. G. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll have 12 numbers of significant figures. H. So I'll have 1, 2, 3, 4, 5, 6 numbers of significant figures. Again, this zero here is not significant from the rule zeros appearing before non-zero digits are not significant. I. So we'll have 1, 2, 3, 4, 5. Yes, we'll have five numbers of significant figures. And lastly, we'll have two answers for that. It might be 4 or 5 significant figures. From the rule, zeros at the end of a number without a decimal point may or may not be significant. Okay, so we have an example here. What is the correct way to express the following arithmetic operations? So take note that there are rules in operation with significant figures, particularly in adding, subtracting, multiplying, and dividing. So for example, we have 3.01 kilograms being added to 3.32 and 5.1 kilograms. So the result will be 10.43. The rule in adding or subtracting is simply the number of decimal places in the result should be the same as the least of decimal places and any of the number being added or subtracted. So for example, the answer here it would be 10 point something. So it would be determined to which of this has the least number of significant figures after the decimal point. So this one has 2. This one also has two numbers of significant figures. This one has one number of significant figure. So therefore, your result out of these numbers, this one has the least number of significant figures after the decimal point. So our final answer would be 10.4 kilograms. For letter L, we are multiplying 13.03 seconds to 123.1 seconds. So the result would be around 1603.1313 seconds squared. So again, the rule in multiplying or dividing is simply the number of significant figures in the result is the same to the least number of significant figures being multiplied or divided. So again, this number here has 1, 2, 3, 4, 5. So it has five numbers of significant figures. While this one has 1, 2, 3, 4, so you'll have 4 numbers of significant figures. So your result must have 4 numbers of significant figures. So therefore, our final answer would be 1,603 seconds squared. Okay, for letter M, we'll have 8.9921 amperes subtracted to 2.63 amperes. So this will be the result, 6.3621 amperes. So again, in subtracting, the number of decimal places in the result should be the same as the least of decimal places being subtracted. So we'll have 6 point. Okay, we'll determine the decimal places to the numbers being subtracted. So which of these has the least? So this has 1, 2, 3, 4. I mean the least number of significant figures. So this has 4 numbers of significant figures, and this has 2 numbers of significant figures after the decimal point. So our final answer must be 6.36 amperes. Okay, for letter N, we are dividing. This time we are dividing 1.419934 pounds to 62 pounds. So this will be the result. So again, in multiplying and dividing, our number of significant figures in the result should be the least. Which of these two has the least number of significant figures? So this one has 1, 2, 3, 4, 5, 6, 7. So while this one, 62, has only 2 numbers of significant figures. So therefore, your final answer must have 2 numbers of significant figures. So 0.023. Okay, there's no unit since it's being divided, so mag-cancel out ang units. At the same time, these two zeros here are not significant. At the same time, you'll have 0.023 since you'll have to round this off since the adjacent side of 2 is 9. Okay, lastly, we'll have 3.21 seconds being subtracted to quantity enclosed in a parenthesis 4.33 times 10 to the minus 6 meters per second divided by 2.7 times 10 to the minus 5 meters per second squared. So we need to resolve first these numbers being enclosed in the parentheses. So you'll have here, it's being divided, so you'll have 3.221 seconds minus, so the answer when dividing these two is simply equal to 0.1603704 seconds. So take note the unit is in seconds since you need to cancel this one out, meters, and also the second. So you'll have 1 second left here. So here, these numbers has 3 numbers of significant figures, while this one has 2. So therefore, from this answer, which is too long, so you'll have here, you'll have to get 2 numbers of significant figures, so you'll have 0.16 seconds. So again, you'll have 3.221 seconds being subtracted to 0.16 seconds. So your final answer would be, okay, the rule again in subtracting is simply you'll have the least number of significant figures after the decimal point. So this one has 1, 2, 3, 4, while the other one has 2. Okay, so your final answer would be 3.0606 and so on seconds. So the final answer rather would be 3.06 seconds. So this would be its final answer.